Welcome back. We are on lesson 4 of module 4. The objective for today's lesson is use tape diagrams to model fractions as division. So for part 1 here, or number 1 here, A through D, we're not going to model the tape diagram. We'll use that tape diagrams for the rest of the problem. So let's go ahead and get started. And if you pay attention to the last video, you'll notice that lesson 3 is very similar to what we have going on right now. So let's take a look. Our directions tell us to fill in a chart, and the first one is done for us. So A is done for us. And for our division expression, we have 13 divided by 3. Fraction, we're just going to put 13 in our numerator, and 3 is our denominator. And we know that 13 divided by 3 falls between 4 and 5. And we can see here that it would be 4 1/3. So we're going to save this column here for after we do our standard algorithm. All right? So let's go ahead and get started with B here. So B says 6 divided by 7. We should know at this time our first number is our dividend and our second number is our divisor in our expression. So it's going to look very similar in our fraction. Our dividend goes up top. Our divisor goes down the bottom. We know that it's greater than 0 but less than 1. So 6/7 falls between 0 and 1. Let's go ahead and divide that. 0 wholes, because 6 divided by 7 is 0. We can't do it. 0 times 7 is 0. 6 minus 0 is 6. We will have a remainder of 6. 6 what? 6/7. So we know that that's going to be what our standard algorithm will look like. Let's go ahead and look at C. So for C, our fractions given to us. We have our numerator up top. We know that's going to be the same thing as our dividend. And our divisor at the bottom is our denominator. Now we know that this is greater than 1 whole. So I said we're going to come back to this. After we do our standard algorithm, we'll come back to this column here. And we'll base it off of our fraction as well. So let's take a look. We know that our top number, our numerator, or if we're looking at our expression, our dividend is going to be underneath our fraction house in the standard algorithm. So we have 55 divided by 10. 5 tens, I couldn't divide it by 10 people. So I would say, well, 55. How many tens can I get out of 55? We know it's 5. 5 times 10 is 50. Subtracting, I have 5 left. And it's 5 what? 5 tenths. So we can see that this is 5 5/10, which is also equal to 5 1/2. So we know that this will fall between 5 and 6. All right? If we wanted to do another way, we could do our number bonds. I'm just going to make a whole bunch of 1s here. That's 1. 10/10 is equal to 1 whole. Then I have another one. Another whole. That's 2. Another whole here. 3, 4, 5. Now if you look at it, 10, 20, 30, 40, 50 tenths. And then I will have 5 remaining. And we can see that it's 1, 2, 3, 4, 5 wholes. 10 tenths is equal to 1 whole. And then we have 5 tenths remaining. So that number would actually be directly in between. If we had a number line here, this was 6 and this was 5. 55 tenths would be right there, smack in the middle, the midpoint between 5 and 6. 32 over 40. We know that this is going to be less than 1, but greater than 0. Right? Because it's a proper fraction, not an improper fraction. Where in the proper fraction here, our numerator is less than our denominator, so we know it's going to be less than 1. 32 divided by 40, and we have 32 divided by 40. I mean, if we had $32 and we wanted to divide it by 40 people, no one would get a whole dollar because we don't have enough dollars to give everybody 1 whole. So we would say, well, 40 times 0 is 0. And then we have 32 minus 0, 32 40ths. that's what our standard algorithm would look like. All right, moving on to the next page, and this is where our objective is going to come into play. Like I said, this was more of a review of lesson 3, and then we're going to use our tape diagrams for the remaining problems. So we have Greg spent $4 on 5 packs of sports cards. We're trying to find out how much did Greg spend on each pack. So we have a couple things we need to do here. And we're going to use our read, draw, write strategy. So we read the problem. We know that we're trying to find out how much money he spent on each individual pack. So first thing we need to do is let's go ahead and draw our tape diagram to help us out here. So we know that there were 5 packs. So I know 4 lines will give me 5 packs. So I'm going to put my 4 lines. 1, 2, 3, 4. So now you can see my 1, 2, 3, 4, 5 packs of cards. My whole is the $4 that he spent. I'm just going to put my $4 up top. Now what I want to do is say, well, if I know that $4 was paid for all of the cards, all 5 packs, we're trying to find out how much one pack costs. So we know that 1, 2, 3, 4, 5 packs, or 5, we'll just call them units here. 5 units equaled a total of $4. So if 5 units equal $4, then 1 unit is going to be $4 divided by 5. So we know that $4 divided by 5 is equal to 4/5. Right? So let's see. 4/5 of a dollar, 4/5 of a dollar, 4/5 of a dollar, 4/5 of a dollar, and 4/5 of a dollar. So that would be 1, 2, 3, 4, 5. That's 4, 8, 12, 16, 20 fifths of a dollar for the total, which is equal to our 4. Right? So we know that that's accurate. So now we have to say, well, how much does this translate, this 4/5 of a dollar translate when we're talking about money? So if $1 is equal to 5/5, how much would 4/5 be? That would be the same as us saying we have $1 in each. The dollar was split into 5 parts. That would be 20, 40, 60, 80. One whole dollar, we say 4/5 of a dollar is equal to 80 cents. So 80 cents is our cost for each pack. 4/5 of a dollar, which is equal to 80 cents. All right, and now we're talking about part B here. If Greg spent half as much money and bought twice as many packs of cards, how much did he spend on each pack? Explain your thinking. So let's take a look here. It said he spent half as much money but bought twice as many cards. All right? So a couple things. Now we're going to say instead of 1, 2, 3, 4, 5 packs, he bought twice as many. So let's make this tape diagram a little bit bigger. And he spent half as much money. So instead of having $4, we know he spent half of 4 is 2. But he bought twice as many packs of cards. So let's go our 9 lines. We're going to go 1 in the middle and 4 on each side of the pack. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So now we're going to see if how much is one going to cost. 10 units equal $2. Then 1 unit equals $2 divided by 10. We know that 2/10 is going to be equal to 20 cents, but let's go ahead and work the math out. 1 unit is equal to 2/10. 1/5 of a dollar, which is equal to 20 cents. Remember, if we had a dollar, split into 5 parts, probably 20, 40, 60, 80, $1. 1/5 would be what we're looking at here, which is our 20 cents. 1/5. 1/5 is equal to 20 cents. So that's how we would get our answer for part B. All right, let's take a look at the next problem here. So we have 5 pounds of bird seeds is used to fill 4 identical bird feeders. We have 4 bird feeders, so we're going to need 3 lines to give us our 4 identical bird feeders, 1 in the middle, and then each half. So now we know that this up here, our whole is going to be our 5 pounds, which is called a 5, and we're trying to find out 1 bird feeder right there. All right, so we're going to say, it says, what fraction of the bird seed? So we know that it's going to be our answer here. They don't want us to solve for this first part. They just want us to say the fraction of the bird seed is going to be 1/4 of the bird seed, which is 5 pounds. So they're just looking for this right here. They're asking us what fraction of the bird seed. So we're going to find out how much bird seed is used in each feeder. So we're going to solve for this now. So we don't need this tape diagram down here. Get rid of that. We're just going to go ahead and multiply. Multiplication, so we know 1/4 of 5 is equal to 1 times 5 over 4, which is equal to 5 over 4, which is also equal to, remember, 4/4 should be a whole, then I'll have 1/4 remaining. So we need 1 pound and 1/4 of a pound. Okay, so that would be, each one would have 1 pound and 1/4, 1 pound and 1/4, 1 pound and 1/4, 1 pound and 1/4. And if you notice, it's 1, 2, 3, 4 whole pounds, and then 1/4, 2/4, 3/4, 4/4, because that's equal to 4 and 4/4 is equal to 5. All right. And now we have to do some converting here. Part C is asking us how many ounces of bird seed are used to fill 3 bird feeders. So we're just looking for 3 now. And remember, we're looking for ounces instead of pounds. So we're looking for ounces, and we're looking for 3 bird feeders. So let's go ahead and do the conversion. We know that 1 pound is equal to 16 ounces. So now we're going to say, well, if 1 pound is equal to 16 ounces, then 5 pounds is equal to 16 ounces times 5. So we know that all 5 pounds will be equivalent to, that's going to be 80 ounces. 5 pounds equals 80 ounces. So we can say 80 ounces, and we have 4 items. So now we have 80 ounces divided by 4 bird feeders. That's what we have here. So instead of having our 5 pounds, that would be 80 divided by 4. And if we need to see that, let's go ahead and look at that on our tape diagram. We made the conversion, and we said that 5 pounds is equal to 80 ounces. So now we would have the same thing here. We would just have our 80 ounces divided by 1, 2, 3, 4 containers, and we should be able to see that 20, 40, 60, 80 in all 4. That's 80 ounces, 20 in each one. So we're trying to find out how many ounces is in 3. So that would be 60 ounces. 80 divided by 4 equals 20, and then we have 20 times 3 to get our 60 ounces in 3. All right, hopefully this helped you. If you have any questions, just drop a comment below. Don't forget to like and subscribe. Boys and girls, keep working hard, and I will see you later.